Now, today's lesson is going to be all about recurrence relations. So basically, this is a different way that we can write a sequence. And sometimes how we want to write these sequences, we want to write them as a relation in terms of what the previous term was. The benefit of this is if we're putting this on our calculators, or if indeed we're using some sort of computer software, it just makes it really easy to compute the next term in the sequence. So for example, if you start with a value of 4 and you generate the next term by adding 3 to the previous term, then you would have a recurrence relation such as this, where you always take the previous term and then you add 3 to it to get the next term. So that's what we mean by previous term and next term. If you've got your un, your next term is your un plus 1. Sometimes this might be un minus 1 and un, or it could be un plus 1 and un plus 2. Okay, so you just need to kind of look at it as in what is the relation from the last term to get to the next term. Now let's look at a few examples. Our first one, we've got this recurrence relation here. So un plus 1 equals un plus 4. What this means is take the previous term, add 4 to it to get to the next term. So if I know that u1 is 7, so if I want to find u2, I just need to do u1 plus 4. Okay, just check all the n values work. So if you've got u1 here, n plus 1, 1 plus 1, you've got u2 here. So to find u2, you just do 7 plus 4, which is going to give you 11. To find u3, you now do u2 plus 4. So you take your previous answer, which was 11, you add 4 to it, and you get 15. Your fourth term, you take your previous term, which was 15, you add 4 to it, you get 19. And we can probably see at this point that this is just an arithmetic progression because I'm just adding 4 each time. I've got a common difference of 4. The next one, just before I go through this, can you tell me anything different that happens with this sequence? So just have a look at the sequence, see if you can find the first few terms, and in the chat, if you just want to write down your thoughts, what happens with this sequence? Why is it a little bit different from the last one? The last one was just an arithmetic progression. But what's particularly interesting about this one? So think about what your second term is, think about what the third term is. And just pop your thoughts in the chat below. Okay, excellent, got some comments coming in. So first term is 3. Sometimes you're taking away, sometimes you're adding. Alternating between negative and positive. Yep, so let's have a look at what happens. So our first term is just 3. Then to find the second term, well, we do 2 minus the first term. So the first term is still 3. Okay, so the first term is still 3. It's just 2 minus un is the rule that I use here. So to find u2, I'm just going to do 2 minus 3, which gives me minus 1. To find u3, I do 2 minus the previous term, so that's 2 minus minus 1, which gives me positive 3. Now I know that when I put in positive 3, I just get minus 1. When I put in minus 1, I know I get positive 3, and so on. So this sequence is always going to go 3 minus 1, 3 minus 1, 3 minus 1. It's what we call a periodic sequence. Okay, so you might see that term come up. This is a periodic sequence. Okay, of order 2, because there's basically just 2 numbers that's alternating between. Some periodic sequences, we saw one in the lesson on Friday, it could go like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That would have that'd be a periodic sequence of order 4, for example. Then looking at this other example, so it's a little bit different, this one. We've got, I'm just going to quickly check the chat. Okay, nothing there. So we've got un plus 1 equals 5un minus 2n. So n is just for what term in the sequence you're looking at. So it's not your u1 or u2. It would just be 1 or 2 or 3, for example. It would just be an integer. So to find u2, I've got to do 5 times u1. Okay, so if this is u2, okay, then your n must have been 1 here. Okay, 1 plus 1 to make the 2. So I put in u1, which is 3. And then in this case, n is just, sorry, not. And then n is just 1 here. I think in my notes originally I did this incorrectly, so I'm just going to have to improvise here. So if I'm putting in n as 1, I've got u2 here, and then 5u1, and then minus 2 times 1. So this is just going to give me 13. And then for the next term, I'm going to be doing, sorry, it's now 5 times 13. So 5 times u2, take away 2 times 2, because in this next one, I'm putting in n equals 2. So this is 2 plus 1, so u3 to get this term here. Then I'm doing 5 times u2, so 5 times 13, because u2 was 13. And then minus 2 times n, and n is going to be 2 here. Okay, because this term was u2, this term was u3, because n was 2. So when I do that, I'm doing 65, take away 2 times 2, which is 61. Then to get next term, I'll do 5 times u3 minus 2 times 3. So this would just give me 299. And then for the fifth term, I'm going to do 5 times 299, 5 times the previous term, minus 2 times 4. So I believe in the notes, you might just want to check, because I think this might actually be incorrect in the written notes. So you might just want to check them, unless I've made a mistake here. But I think originally I made that mistake of using the wrong value of n. So I end up with 7,425 as my final answer. And there's no particular pattern with this sequence. There's no common difference, no common ratio. It's not periodic. It's just a kind of unknown sequence here. So just showing you the different types of sequences you can get. Sometimes it might be just checking why it is n 2 for u2. So the reason why n is not 2 for u2, so when you look at this sequence, you've got un plus 1 equals 5 un minus 2. So if I substitute in n as 1, well, 1 plus 1 gives me u2. Okay, so I'm just going to do this as u1 plus 1. And then I've got 5 times u1, okay, because I'm just putting in n as 1. And then I'm minusing 2 times 1. So I'm just going to highlight here. In the first bit here, this is what n is. For the next row, I'll be doing u2 plus 1. So un plus 1, that's 2 plus 1. So that's 5u2 minus 2 times 2. So in this case, n is going to be 2. Is that making a little bit more sense? Okay, I can't see anything in chat, but just let me know if that's still not clear. But we'll move on to the next bit. But please pop your questions in the chat if you're still not sure. I'll be happy to kind of go through it. So another type of sequence that you might have seen quite a number of times before is the Fibonacci sequence. Okay, it's a sequence that you find a lot in nature, for example. A lot of, I think there's certain flowers that only have a certain number of petals that are in this Fibonacci sequence. It's something to do with how the genetics of it all work. So we've got the sequence here. So you probably know it in words, the Fibonacci sequence, that you add the two previous terms to get to the next one. Well, essentially what that's saying is you do un plus 1 to get un plus 2. So if our first term is 0 and our second term is 1, to find u3, what I need to do is u2 plus u1. Okay, so look at the sequence there. If I put n as 1 plus 2, that's u3, n plus 1, that's u2, and then just n on its own, that's just 1. So we do 1 plus 0, because u2 is 1, u1 is 0, we just get 1. u4, we just go to u3 plus u2, so u3 is 1, u2 is also 1, so 1 plus 1 for 2. u5, that's just going to be 2 plus 1 for 3. u6, you're going to take u4 and u5 and add them together for 5. And for u7, we take u5 and u6 and add them together, and we get 8. Okay, and that is what we know as the Fibonacci sequence. Looking at the next example then, the sequence is generated using un plus 2 equals k, un plus 1 plus un, with u1 equals 2 and u2 equals 5. Find expressions for u3 and u4 in terms of k. It's a little bit hard to type out the second one, so I'm not going to put that in the chat. But can you first start off by giving me a expression for u3? Okay, so in the chat, can you give me a expression for u3? So what would u3 be in this example? Okay, excellent. I've got a lot of 5k plus 2s. Well done, Tilly. Well done, Thea. Well done, Yuck. So we've got 5k plus 2. All I've simply done there is if I've got u3 at the start here, then I have a u2 for my un plus 1, and the un is just going to be u1. So I've just got 5 times k plus the 2 there. Then for u4, well, what I need to do there is k times u3 plus u2. So if you've got u4 here, un plus 1, that's just 1 less than un plus 2 in terms of the order in the sequence. And then un is going to be 2 terms before the un plus 2 term. So for u4, I need to substitute 5k plus 2 for u3. And for u2, I just simply put the 5 there. Then what I can do is just expand this out and simplify. And I'll get 5k squared plus 2k plus 5. So I've got my u3 and my u4. In part B, you're told that u4 equals 21, and we need to find the possible values for k. So what we can say is 5k squared plus 2k plus 5 equals 21. So I know that fourth term has to equal 21. So I know 5k squared plus 2k plus 5 equals 21. We want to take 21 from both sides because then we have a quadratic which we can factorize and get the following. And then we just have our two solutions there. One key thing to look at is this question does say values of k. So that implies that there's more than one. So I'm fine here to have both a positive and negative solution. K is just a constant there, so it doesn't matter if it being positive or negative. It could be either two of these and still generate the sequence that's talking about in the question. So yeah, some questions we might just disregard the negative, but that's usually when we're talking about what n is, the number of terms. But here it could be positive or negative. We're just talking about this constant k. If you've got any questions, let me know. Otherwise, I'll move on to example 4. Now in example 4, again, another sequence as we're given here in terms of this recurrence relation. And we're told that A1 is P and that n is greater or equal to 1 where P is less than 0. The first thing we have to do is show that A3 is going to be P to the power of 4 minus 2P squared. So firstly, I want to find the second term. So to do that, I need to do the first term squared and then minus 1. Okay, remember an plus 1 is the next sequence. It's the next in the sequence after an. So a1, I'm told, is p. So a2 is just simply p squared minus 1. A3 then, I just have to do a2 squared. So I do the previous term squared and then minus 1. So this is p squared minus 1. All squared, and then take 1 away from that. Now remember, obviously this is a bracket that is being squared. We certainly don't just square the individual terms. We need to think of this as p squared minus 1 times p squared minus 1. So I'm just expanding that bracket. So I get a p to the power of 4. I get a minus 2p squared, and then a positive 1 when I do the minus 1 times the minus 1. Okay, make sure that, if you want to take the extra step and write out both brackets and expand it all, then you can do that. Then I have to take away that 1 at the end. So the 1s cancel, which just leaves me with p to the power of 4 minus 2p squared. Part B then says, given that a2 equals 0, find the first value of p. Now I know that a2 is p squared minus 1, which just equals 0. So either I can add 1 to both sides and add square root, or we can just spot that this is the difference of two squares. And I'm just going to do this because it's always good to remind you that you can factorize things like p squared minus 1. And we get p equals minus 1 and we get p equals 1. Read the question carefully. You're told that p is less than 0. So actually in this case we want, we'll cross that out. We want the negative solution. But the negative solution, and we disregard this positive one. So since p is less than 0, our solution is p equals minus 1. Part C wants us to find the sum of the first 200 terms. So just going to put this question in the chat. How do you think we would do this? Find the sum of the first 200 terms. We know the first term is p, so we know the first term now is minus 1. We know the second term is 0. Any ideas how we'd find the sum of the first 200 terms? I mean, what would A3 be, for example? What would A4 be? Can we see any patterns? So what do we think the sum of the first 200 terms would be? Or just put down your thoughts about strategies or anything you've discovered along the way about the sequence. Or even just what would A3 be? So we know A1 is -1, A2 is 0. What would A3 be? So don't worry about finding the sum of the series. Just can anyone tell me what A3 is? So A3 is -1. So then we need to decide what. So I think what we should also do is find A4. So to find A4, we'd then sub in our -1 into p to the power of 4 minus 2p squared. So this is -1 to the power of 4, which is +1. Then you'd have to square the -1, which is also +1. So you do 1 take away 2 times 1. So that would end up just being 1 take away 1. Sorry, no, that was to find P3, wasn't it? Sorry. But what you then should be able to spot is if you then look at the original sequence above. So yeah, so don't sub it into 1 with P. If you look at the original sequence above, if you put in A3 into there, so square your -1, you're going to get +1. 1 take away 1 is going to give you 0. So A4 is going to be 0. So I'm saying there's some -50. I think you're close there. Callum. Let's have another think about it. Your first term is -1. Okay, then your next term is 0. Then you go -1, you go 0. If you just look at the sequence that I've highlighted in green right at the top, you've got 0 squared -1 to get next term, which is going to be -1. So your next term would then be -1, and then the term after that would be 0. Okay, so it's always going to alternate between -1 and 0. So it's not an arithmetic progression because there's not a common difference, because you add 1, but then you take 1, then you add 1, then you take 1. So it's not a common, even though it's a similar pattern, it's not a common difference. You're not adding the same amount each time. What we could do is we could group the -1 and the 0 together, which gives us -1. And if I'm looking at the first 200 terms, what I'll find is I've got 100 pairs of -1 plus 0. So all I simply need to do is just 100 times -1, which will just give me -100. Yeah, that's it, Callum. Well done. Okay, if you've got any questions, let me know. And we're just going to move into some past paper questions now. I might maybe skip one of the ones at the end, but I'll definitely want to do this one here. So I might running a little bit late, so I might just skip one of the ones at the end, but I will do this one. Now, our first question for the past paper questions, we've got a sequence where u1 is 8 and un plus 1 equals un plus 3. So this is our recurrence relation. And we just need to show first off that u5 equals 20. Nice and simple, this one. If u1 is 8, well, to find u2, I just take the previous term, add 3 to it to get to 11. and just keep on taking the previous term, add 3 to it. Remember, with these recurrence relations, you can just use the answer function to quickly get there on your calculator by just using the answer function. So just put in equals 8 and then just do answer plus 3 and then just keep hitting equals, and you can get all the terms in your sequence that way. So we've shown that our fifth term is just going to be 20. For part B, this is going to be the bit that's a little bit more trickier. Find the value of n such that this relationship here with sigma, which we met on Friday, is satisfied. So what we need to notice here is that we have an arithmetic progression from part A. So we've got an arithmetic progression where our first term is 8 and we have a common difference of 3. Also, what I know is the sum of the first 2n terms minus the sum of the first n terms gives me 1,256. Okay, so remember this notation from Friday. If it's the sum of all the UNs, that just means sum of U1 plus U2 plus U3 in terms of the first term here, all the way up to U2n. For the second term in this, it's just U1 plus U2 all the way to UN. Just adding the sum of all those terms together, and we do one minus the other, you get 1,256. So what I'm going to need to do is set up some formulae where I'm not going to know what n is, but it's going to be something I need to find out. And to do that, we're going to make use of the formula that we've been using quite a bit. Just remind you of it just in case. We want to use this formula here. Okay, and you do get given that in the formula book, remember. So we're just going to use that formula here. We can't really use the one with L in because we don't know what the last term is. So we need to use this slightly longer version here. So first off, I'm going to use this formula, but replace n with 2n. And then replace a with 8. Yet again, replace n with 2n. And then that's how we'd find the sum of the first 2n terms. Then what we're going to do is use that formula again, but now just with n, because that's the next part of this equation I've got. So I do n minus 2, and yet again, still using the same value for a. The first term is still 8. Doesn't matter if you go into n terms, 2n terms, the first term is still 8. And then we've got n terms for the second part, so just keep it as n minus 1. And then times it by that common difference, d of 3. And I know that equals 1,256. From here, it's really just a case of doing the algebra. So what I'm going to do first is I'm going to times through by 2 to get rid of these fractions. And I'm going to simplify what I've got in the bracket. So in the first bracket, 2 times 8 is 16 plus 2n times 3, so that's 6n. And then also I've got to take away 1 times 3. So this is just 16, take away 3 for 13. And then I've got 2n times 3 for 6n. So this is 6n plus 13. I'm timesing everything by 2, so this just leaves me with n. And then I've got 16 minus 3 again, but this time I've only got 3 times n, so I've got 3n plus 13. And then 2,512 here because I've times all terms by 2. Then what we're going to do is just simply expand everything out and then collect all the terms. So you've got a 2n times 6n here, so you've got 12n squared, 2n times 13 for 26n, minus n times 3n for minus 3n squared, and then a minus 13n, and we've got 2,512. Collect together your n squares, collect together your ends, and add, and then subtract this 2,512 from both sides, and then just simply use your calculator to find the solution here. N has to be a positive integer, so I just take that n equals 16 as my solution here. The minus 157 over 9 is not an integer and it is not positive, so I wouldn't take that as a solution. So let me know if you've got any questions there. I think what I'm going to do is, I think I'll go through the last one, but I'm going to leave this example here. The only difference really with this one is it's just an example with a geometric progression instead. So what you'll find with this question, have a look through the notes that were supplied and make sure you fill that in. But the only difference here really is that this is a geometric progression. Because I've overrun a little bit, I'm going to skip past that example. But that one shouldn't be anything that's too new. It just basically works out as a geometric progression. So I'll very quickly go through this 3-mark question at the end here to finish this off for today. We've got a sequence where the first term is U1 and the sequence defined by UK plus 1 equals 10 over UK squared. So do 10 divided by the previous term squared to get the next term. That's how we would say it in words. Now the second term, that's just going to be 10 divided by 2 squared, which just gives us 5 over 2. And then we do 10 divided by U2 squared, so 10 divided by 5 over 2 squared to give us 8 over 5. And you could at this point just simply put this all in on your calculator and just hit equals with 2 and then just do 10 divided by answer squared and then just keep hitting equals and it will tell you the second, the third and the fourth term. Which is a nice kind of quick process to get those other terms in the sequence. Now we're asked to calculate the first to the fourth term. So that's why I've just found the first, second, third and fourth terms in the sequence. So it's just really another way of getting used to that sigma notation. All you've got to do here is just find the first, second, third and fourth terms. So all I simply need to do to find this is I simply just add U1 plus U2 plus U3 plus U4 together. Which gives us 1,601 and 160. So that is our final answer, and that is another Pure Handbook completed. So that is the end of Pure Handbook 10. So there's no more extra things that you need to learn about sequence series, but it's important that you do the practice. So make sure that you have a look at the questions that we've supplied today and hand them in as promptly as you can. In terms of this week, so what we're going to do going from here on in for this week is on Tuesday and Thursday, rather than have normal sessions, I still will be on here at 11 o'clock. So I still will be on here at 11 o'clock. But instead, it's just going to be kind of like an online prep, if you will, where just come in with some questions, ask away. I'm not going to kind of have anything planned in terms of ones I'm going to definitely go through, but it's really just your chance to come in and ask questions in the chat, or like with this one, what I would say is different to these live sessions. Turn on your mics and then just have a discussion. You know, I'm not expecting as many people as normal to be in this session, so really it's a case of having that extra support there and just to kind of go through any questions that you have with normal distribution or binomial distribution. On Teams, you should have seen this post that I've highlighted here. So this is just in the revision channel. Okay, so just go into the revision channel. It will look different on your phone, I know, but if you've got a laptop, it will look something like this. And then just have a go at some of the questions that I've attached there. So there's some on normal, some on binomial. Just remember some of the older normal questions that I put in. You might find that they're worth quite a few more marks just because of how, just because not everyone had the Casio calculators that you have. So they have to use like tables and things like that to do which took a bit longer. So work your way through those questions once you've completed today's work on the pure stuff, and let us know if you've got any questions. And we've got a test on Friday, so really use Tuesday, Wednesday, Thursday to kind of focus on your revision for your test. And so we've got Tuesday and Thursday for you to kind of ask those questions, and just anything you want me to go over again, we can do. So it'll be a bit more interactive on Tuesday and Thursday. I'm going to stop recording here. Let me know if you've got any questions.